Okay, so today we're going to take things a little bit farther and start talking about exponent rules with monomials. These first three examples are directly related to what we saw in the last lesson, 2.5. Definitely watch that video if you haven't already. The exponent rules are as follows. We're multiplying two exponents with the same base. The base stays the same, but the exponent is 6 plus 2 in this case because we're multiplying. This is 3 to the power of 8. When we're dividing, we do the opposite. So the base stays the same as 3, but we're going to do 6 minus 2, which is 4. And when we're taking the power of a power, 3 to the power of 6 to the power of 2, we basically just multiply both of those exponents, and that's 3 to the power of 12. Today's lesson is actually really just about realizing that the same rules apply if the base happens to be a variable. So the same exact rules that were above are going to be in effect because x to the power of 6 means x times x times x times x times x times x, all multiplied by x squared, which means multiplied by x times x. So in total, you have x to the power of 8. The same rule applies for division. So again, it would be the 6 minus 2, which gives us the 4, and to the power of a power, which would give us the x to the power of 12. So the exact same rules apply because x represents any number, not just 3, not just 4, not just -5. X represents anything. So these same rules would apply as long as we're dealing with the exact same base. So let's think about a few examples really quickly, okay? So I want you to pause your video now, try these examples, and when you unpause it, we've got the answers up there. Okay, so as per usual, I'm going to take these one at a time. The first example is rule 2. So we're dividing, so we would subtract those two exponents. We wind up getting a to the power of 6. Question B is actually rule 3. We multiply those exponents. We get a to the power of 27. And C is actually good old rule number 1. We're adding those exponents. Same base in all three of those cases. Talking about A. Question D is a little bit more complicated, right? Because we've got kind of what looks like a fraction going on, and we've got two different variables going on. Well, let's break it down a little bit here. On the top, we've got x to the power of 4, and then we're going to take that to the power of 2. That's a power of a power rule. So on top, we should have x to the power of 8. Would that affect the bottom, though? Well, it does, so there's the answer, because if you think about squaring something, we shouldn't forget that to square something means to take the thing that is being squared and multiply it by itself. So we'd take that and we would multiply it by itself. Now, if we multiply it by itself, you'll notice by rule 1 that the top actually does wind up being x to the power of 8 because 4 plus 4 is 8, and y to the power of 6 because 3 plus 3 is 6. Okay, so that just sort of explains it. The very last one is just to remind us of a pretty basic principle, right? At first glance, it should be m to the power of 7, right? Because 3 plus 4 is 7, and there's nothing there. Well, be careful with that. There is one m there, right? That is actually m to the power of 1. It's not m to the power of 0. So 3 plus 1 plus 4 does make the power of 8. Okay. So here are 4 more examples. I want you to pause the video, consider them, and the answers will magically appear. All right, so these ones present a few interesting new challenges. With question F here, there's the answer. You'll notice that we've got y to the power of 5 and z to the power of 3 both inside those brackets. And because they're inside of the brackets and then being raised to the power of 4, we have to use rule 3, but we have to use rule 3 for both of the exponents. So this can be written as y to the power of 5 to the power of 4, which is y to the power of 20, and z to the power of 3 to the power of 4, which is z to the power of 12. So that's an interesting one. Noticing that it's very similar to distributive property, but not exactly the same. Just don't forget that the 4 applies to both of those exponents because they're both inside of the brackets. Okay? With question G, a similar problem, right, happens. We're going to basically do the same rule with the two separate terms because x and x are the same bases. We won't forget that that's the power of 1. We'll get 5 minus 1, which is 4, the exponent for x. And here we'll get y to the power of 6 divided by y to the power of 2, which gets us y to the power of 4 right there. This next example, really similar again. Here, because order doesn't matter when we're just multiplying, we're going to choose to just multiply the a's together first. Because they have the same basis, we can use that rule. That is a to the power of 1, so 1 plus 3 is going to get us that 4 that's here. Same thing happens with the b's. So we're going to take the b to the power of 2 and the b to the power of 5. 2 plus 5 gets you the 7 there. This last example kind of combines G and H together, or G and F together. This power of 5, don't forget that it doesn't belong just to the y, it belongs to the x and the y. I mean, if you think about it, there's a 1 written here in front of the x, or behind the x, and there's a 1 written there behind the y. So all of that to the power of 5 means to take xy, multiply by xy, multiply by xy 5 times. So we wind up with 5 x's being multiplied together and 5 y's being multiplied together. We just copy the x to the power of 3 on the bottom. We then use our rule 2 with our x's. X to the power of 5 divided by x to the power of 3 gets you the x squared. The y to the power of 5 doesn't get divided by anything, so it still stays a whole number. I mean, technically, if you want, it's over 1, but we don't have to write that. Now let's amp it up even more. So some more examples. Thinking about these, I'll do the first one before asking you to pause the video. Because we're only multiplying in all 4 of these examples, we can actually cheat a little bit in terms of our simplification by doing this. That's the number 3, and that's the number 2. Inevitably, you're going to take 3, multiply it by m, multiply it by 2, and multiply it by m. But we know what 3 times 2 is. 3 times 2 is 6. And we know, based on the last slide, that m times m, that's power of 1 and that's power of 1, is simplified as m squared. So why not use that same principle for all 3 of the remaining examples? Go ahead, pause your video now. The answers will show up. Alright, so if you follow that example for question A, you'll notice that we're probably going to multiply the 5 by the 2 first. And you can see I've color-coded it for you. I multiplied the coefficients together because I know what 5 times 2 actually is. It's 10. I also know, because of our exponent rules, a squared times a cubed works out to be a to the power of 5. So we've actually simplified that expression down to 10a power of 5. Example C here, same thing. I highlighted my coefficients in green. 3 times 4 is 12. And I underlined my a's in blue. Again, remembering that that's a to the power of 1 times a to the power of 1. That gets me a squared. Finally, we wind up with b just tagging along because it didn't get multiplied by anything else. You'll notice that the integer math still applies. Here I've underlined my coefficients in blue. Negative 3 times positive 7 works out to be negative 21. And y squared times y to the power of 5 works out to be y to the power of 7. Of course, there are a few more examples here. I want you to go ahead and consider them. I promise those will be the last ones for this evening. So give those a try. Okay, so here are the last 4. Now, these are a little bit tough, so I'm going to work through. I might spend a bit more time. Feel free to fast forward if you need. Here's the answer to question E. You'll notice that the actual coefficient in front of x here is negative 1. That's where it gets kind of tricky, right? So number in front of x is technically negative 1 there. Negative 1 times 2 times negative 4 gets you actually positive 6. Then we don't forget as well that x here is to the power of 1. So 1 plus 6 is 7, plus 3 is 10. And that's where you get your x to the power of 10. Here with example F, pretty straightforward. We're going to take the coefficients, multiply them together. So negative 9 multiplied by positive 2 is negative 18. We then get our a terms together, multiplying them. So a to the power of 5 times a to the power of 1 is a to the power of 6. And the very last one, b to the power of 1 times b to the power of 4 equals b to the power of 5. And again, because we're multiplied, they're all together. They're all one term. G is an interesting example because a lot of people will answer 5x to the power of 6. You're only half right there. This is a power of a power rule, but don't forget that the 5 is inside of the brackets. So the 5 actually also has to be technically put to the power of 3. Okay, so there's a bit of an intermediate step here, is that it's 5 to the power of 3 times x to the power of 6. 5 to the power of 3 winds up being 125, and that's where that comes from. Same thing goes for question H. So the negative 2, because it's inside of brackets, is put to the power of 5. It goes negative because it's negative 2 to the power of 5, so an odd number of negatives. So that's where that 32 is coming from, to the power of 5. So the power of 5 gets distributed in. It also gets distributed into that 4, which gives us x to the power of 20. Don't forget that with all of these things, we could do division questions as well, right? Rule 2 still applies. We haven't really seen any of them, but how about this one if you want, just to sort of ponder before we go? What about 20x to the power of 10, y to the power of 2, divided by 5x to the power of 3, and y to the power of 2? Well, let's think about that as well. 20 divided by 5 is going to be 4. X to the power of 10 divided by x to the power of 3 is going to be x to the power of 7. Y squared divided by y squared. They cancel each other out. In other words, y to the power of 0, which we may have talked about in class would be 1, but 4 times x to the power of 7 times 1 is just 4x to the power of 7. The y squareds cancel each other out. Okay, so you can even do that to cancel them. So division, power of a power, multiplying same bases, those three rules are still in effect when we're dealing with variables. All right. So hope you enjoyed the lesson for tonight. Going to be lots of stuff to do in class tomorrow.